I wanted to go over 793 before your exam. It's another modeling question. It says a company has 200 square centimeters of material, probably aluminum, to make an open cylindrical container with a bottom, no top. How should they design the can so that it can hold as much as possible? So open top cylinder, and we are trying to maximize the volume. How can we make it hold as much as possible? So that's what we're trying to do. So step one, draw your diagram. And draw a picture in here. Looks something like this. Oops. We're going to draw this in. There we go. So it's an open top cylinder. Looks something like this. No top. We also know that we got to identify our variables. So this bottom shape's a circle, so we can call this our radius. We can call this the height of the can. So we have radius will equal r, height is equal to h. We know our surface area, which we'll get to, let's just call that S. This will be our surface area. And V will be our volume. Alright, once we've done step 2, we're going to move on to step 3, where we begin. Actually, let me do step 3 up here. To construct equations that relate to variables. So we'll start with volume, since that might be the most straightforward. So the volume is the area of our base, which is a circle, so it's pi r squared, times our height, which is h. So that's our volume equation. Our surface area is a bit trickier. If we look at the surface area of a cylinder, we first have to think about the area of the bottom piece, which is the circle itself, which is pi r squared. And then we have to add the shape that goes around the cylinder, which actually is a rectangle. If we were to envision us wrapping this around the cylinder, we know that I have a height, and then we don't know our base, but I do know that the circumference of the circle is 2 pi r, and that, when we unfold it, will also be our base. It's the distance around the circle. Okay, that's the same as this measurement. So now that I know that, I can add 2 pi r h. Oops. Now, once I have that equation, I know that the surface area is 200, so I can write 200 equals pi r squared plus 2 pi r h. Now, we want to maximize the volume, and we need to do some substitution here. So step 4, our goal is to maximize the volume. To maximize our volume, if we look at our volume equation, we have 2 of them here. We have 3 variables. Surface area only have 2 variables, r and h. Step 5 here, we're going to use substitution on this 200 equals 2 pi r squared plus 2 pi rh. And it's not 2, it's just pi r squared because we only have a bottom. I made a mistake there. Alright, so we're going to isolate, let's get h alone. Pi r squared. So all of this is equal to h. Alright, now we can substitute into our volume equation for h. So we have 200 minus pi r squared over 2 pi r. Okay. And we want to maximize our volume. We can actually probably just put this in our calculator now that we have it. We could simplify it farther, or we can just put it in now, and we're going to get a quadratic that opens down. Actually, let's graph it. So on the graph, you're looking for the relative max. It's actually a cubic. It looks something like this, but I'm looking for this point right here, which ends up being 4.607 and like 307.1 cubic centimeters. So this is the radius, and this is your volume. Alright, hope that helps with 93.